Hello class, today we're going to start to continue with our previous lecture. So today let's learn what is the derivative of f. Okay, when you look at this equation, what it reminds you of? Okay, you have come across this equation. Okay, where? Okay, so let's go back to previous lecture. This is the instantaneous rate of change, the equation to find the instantaneous rate of change. Okay, let's go back to previous equation. Okay, here. Okay, it is the same. It is also also to find m. Okay, can also be rewritten as this one, as like this. Oh, sorry. Okay. Okay, both of this equation is the derivative of the function f(x) provided the limit exists and it is differentiable at x. Okay. Okay, so from this graph, it says here that f has slope at -1. Slope is equal to m. So the differentiate value is -1. Same as this. Slope means m. M means f prime x. Okay. It is also similar for all three values here. Okay, now let's look at example 1. Okay, so for example 1, there is a solution here, but I will try to explain it to you. So A here is 5 and B is 9. Okay, sorry. Okay, the equation here asks us to use the definition of the derivative to determine the differentiation value of ax plus ax plus b. Okay, use the definition of the derivative. Okay, now let's look back. Okay, this is the definition of the derivative. So we must use this equation to try to solve this example. Okay. So it should be like this. f(x) plus h minus fx over h. So this part here is okay, I'll write it here. So fx is sed ax plus b. Okay, here. Okay, and f(x) plus h is sed ax plus h plus b. Okay, so here it is fx plus h minus fx over h. Okay, now we try to solve it using the conjugate theory. So so for conjugate theory, this part where this part is negative, it will become positive here, and multiply h with this value. So as you can see here, this part here is actually equals to 1. So for conjugate, always remember, multiply this let's say let's say we have 2 minus x. Okay, how to multiply this 2 minus x with its conjugate is we use this. This is the conjugate of 2 minus x. Okay, over 2 minus x. Okay. X, okay? This is a simplified version of what is conjugate. I just want to make sure that you understand. So if you try to simplify this, and you will get this part here, and the final answer should be this. Okay. Okay, the final answer should be this part here. So let's look back at this at example 1b. Using the result in A, find the answer for cert 5x. Find the differentiation value of cert 5x plus 9. So this is really easy. We just include in the value of A is what? A is 5 and 2 cert 5x plus 9. Okay, that's all. Okay, class? So for example 2, I want you to do it by yourself, and I will give you the solution later. For example 3, we have did something similar. Like this one. Okay, we have try to solve this equation using this method. Just this time we are using, this is the function that we need to solve. Okay, theorem for derivative. If f is differentiable at A, then f is continuous at A. Continuous means there is no breaking point. Okay, so for this example, where is the function fx modulus x is differentiable? Okay, where? Okay. So now we try to plot the graph for this function fx, and this is x. Fx is also equal to y. So for x equal or larger than 0 and the value is x, and for minus x, for x less than 0, the value is like this, minus x. Why is it like this? Let's go back to this. Okay, so y equal to x is like this, kan? And if y equal to minus x, it is like this. So for x larger than 0, it is y over x, and for x smaller or equal to 0, it is minus x. So now we want to find the value of fx. Okay, so for f prime x, okay, differentiate x, you get 1 for larger than 0, and differentiate minus x, you will get minus 1 smaller than 0. So now we try to plot the function for this. Okay, so starting from this is the limit. So this is x equal to 1 and this is x minus 1 for x less than 0. Sorry, 1 minus 1. Okay. So what does it mean here? It means that for limit, okay, I try to erase something first here. Okay, we do this again. Okay. So this is for f prime x, 1 for x larger than 0 and minus 1 for x less than 0. Okay, so what does it mean here? Does this limit is the limit from the for f prime x from the right hand side and left hand side got the same value? No, because from the right hand side the value is 1 and from the left hand side the value is minus 1. So limit f prime x does not exist, since the limit from the left hand side to the right hand side is not the same. So okay, this is the answer. If so, the answer, this function is not differentiable, it's not differentiable since the limit is not the same. The limit from the right hand side to the left hand side is not the same. Okay, now I'm sure this is nothing new to you, but this is just like a refresher course. So we try to solve A here. So f prime t should be 11 to the front, and then 11t to the power of 11 minus 1. You will get, okay, and then for this one, g prime t can be rewritten as 6t power half. Okay, bring half to front, and then this 6 here, and then t minus 1. Okay, you will get, okay, so this one, I'm sure you have learned this, I think, in high school. This is easy peasy. So can also be rewritten like that, like this, 6t minus 7. Okay, so differentiate it. This is not the differentiate yet. Okay, now we differentiate it. 6t minus 7 times 6 is minus 42, and t minus 7 minus 1, you will get minus 8. Okay, so for this part here, gx, can you differentiate? Will you get anything if you differentiate e to the power of 3? No, the answer will be 0 because we want to differentiate x here, but there is no x function or x constant in this equation. So the answer should be 0. Okay, now let's look at E. Okay. 5/6W. No, this is not yet. Okay, I'll just rewrite it. Okay, this is the derivative. So put 12 at the front. 12 minus 1. And then you will get here 10W to the power of 11. Okay, this one is really easy. So f prime v is 100v. 100 minus 1, you get 99. And then this part here can also be rewritten like this, over 4, or 1/4 s to the power of half. So try to differentiate it, we get like this. S minus 1. So you will get 1/8 s to the power of minus half. Okay, class. So we move on to the next slide. Okay, if f and g are, for the sum rule, if f and g are differentiable at x, then ddx of fx plus gx is similar as when we differentiate it one by one, f prime x plus g prime x. So now let's look at example 6a. Okay, 6a can also be rewritten like this, d/dt 6/t minus d/dt 4t to the power of 3 plus 9. Then we differentiate it one by one. So 6/t, you will get 3t minus half, and d/dt 4t cube, you will get 12t square. 9? No, because there is no t constant here. Okay, so this is the final answer. Okay, for this one here, again we differentiate it one by one. So f prime x should be 4tx cube minus 32. Okay. Okay. Okay, so now let's look at example 7. So we try to solve a here. So with looking at this, the best answer is we should use the product rule. Okay. Okay, so u here is x minus 1, u prime is 1 lah. 1. Okay. And then v is x cube plus x square plus x plus 1. Okay. And v prime should be 3x square plus 2x plus 1. So how to do it? how to find h prime x? It should be u v prime okay, now we are using, this is a formula for product rule. Okay, so uv prime is x minus 1 times 3x square plus 2x plus 1 plus vu prime should be like this, x square plus x plus 1 times 1. Okay, so this should be multiply 1 by 1. You should get this plus 2x square plus x minus 3x square minus 2x minus 1. Okay, 1 by 1. Okay, and then plus this part here, x, this part here, x cube plus x square plus x plus 1. Okay, final answer, I want you to try yourself. Final answer should be 4x cube. Okay, class? Okay, so now we try example B. So example B, we can multiply it 1 by 1. Okay, because it will be easier that way. So you will get, if you multiply it 1 by 1, you will get x square plus 1 and then plus 1 plus 1 over x square, which should be simplified as this, and then differentiate this equation. You will get 2x minus okay, this one here can be rewritten like this, kan? Okay, so 2x minus 2x minus 3. So the final answer is this. Okay, so now the question is not here, but I want to give you the example. I want to give you the example. Okay, so the question is why 4s cube minus 8s square plus 4s over 4s. So we want to find the y prime for this equation. First we can simplify it. Looking at this equation, we can simplify it. 4s minus 8s square over 4s plus 4s over 4s. So 4s over 4s, you will get 1. So this part here, this one will be 1 and this one will be a slash, and you will get 2. So this one will be 2s here. So this part will be slash and this one will be 2. 4 will also be slash. So the final answer should be not final yet. Okay, the final simplification should be s square minus 2s plus 1. Okay, then only we will simplify it. Y prime should be 2s minus 2. So this is the final answer. So this is C. Okay, I want you to write it down in your notes. Okay, class? Okay, now I want to this is D, so this should be E. Okay, E, Y is 2 third x minus 1 times 4x plus 1 to the power of minus 1. We want to differentiate this equation. So how? This can also be rewritten like this. Minus 1 over 4x plus 1. Okay, now we can declare the upper part as U and the lower part as V. So U is U prime should be can also be rewritten like this. So U prime should be times 2x minus and 1, we can do nothing about that. Okay, so should be okay. So about V is 4x plus 1. V prime should be 4. This equation, this question calls for the quotient rule. This part. Okay, quotient rule. So for quotient rule, okay, this is the quotient rule. So for quotient rule, the formula is like this: VU prime minus UV prime over V square. So VU prime is 4x plus 1 times x. Okay, minus U V prime times 4 over V square. V square is this. Okay. Okay, it can be, sorry. Okay, I'm gonna try again. I don't know what is happening. Oh my gosh, so annoying. But okay. Okay, actually you get the answer here. This is the answer. Okay. Okay. That's all for today. I will post more videos soon. Okay, bye class.